Hey guys, in this video we're going to talk about domain and range, or at least an introduction to domain and range. Later we're going to be talking about domain and range and what it looks like on a graph as far as a function goes, right? As a function is moving, as a function is, changing and going through different phases. Maybe it looks like this, right? Something like that. For now, we're going to focus on domain and range as we're looking at it in a number line. So just either horizontal or strictly just vertical, and how it behaves on a number line. How do we describe it using three different notations, right? Maybe you remember looking at something like this, or vertically, right? What does my function look like? My relationship look like? So we're going to focus for now on number lines, horizontal and vertical number lines as an introduction. We're going to talk about three different sets, and then later we're going to move on into actual functions and relations in two dimensions. Now, before we begin, make sure you have a pencil, something to write with, something to write on, because retention is increased when you are writing things down as well. When you're pausing the video and you take time to actually work this out with me, it is easier for you to actually understand. If you're watching all of these math videos and you're just going through the motions and hearing me, you are going to get some information, but you're not going to retain as much as if you're writing it yourself. So make sure you have something to write with, something to write on, and let's begin. So let's review real quick. Domain and range. Domain is a set of values of a function or a relation, the x values. So when we're looking at x values, we're usually talking about horizontal. We're looking at what values does x take place, right? Does x exist from negative infinity to positive infinity? And here, like I said, we're going to talk about a number line. What is the smallest number that it goes to? What is the largest number that it goes to? And maybe it's just integers, things like that. The range is a vertical range of values, right? Because we're looking at sort of like usually the output of a relation or the output of a function. So when we're dealing with y, we're looking at the vertical distance, either vertically upward or downward. So let's talk about the three notations. We're going to be dealing with three different notations here. Now, there's one that you're probably very accustomed to from Algebra 1 called the inequality notation, and maybe even the set builder notation. But we're going to be talking about three different notations, and I'm going to show you how all three of them are connected, how they're similar, how they're different, and then ideally we'd be very comfortable doing all three different notations and be able to interpret and understand what we're talking about. So the inequality notation is when we're using the inequality symbols. Usually you're going to see a function written as something like this, like x is between two values, right? The smallest value and then the largest value. Or maybe you're looking at y, and you can also use less than or equal to if it's including the point, right? Maybe y is between two values. So the domain and range can be written with inequality symbols like these. And we're always going to be using the less than symbol because we're always going to be talking about least to greatest, least to greatest. The interval notation is very similar. The interval notation is not going to have the x and the y because it is assumed that when you're talking about domain, you're talking about the x values. So instead, you're going to be using parentheses to talk about the range of values. So you're going to usually you're actually always going to put the smallest value here first and then the largest value here. So notice how here we have the smallest and largest, so we would just copy this number here and this number here. For the range, we would do the same thing, except that we would write the letter R for range. And you either use parentheses or brackets or a combination. Now here, because I'm talking about the range from before, I'm going to be putting the brackets. Now I will get into that here in a little bit, but usually, or when we're talking about inequality symbols, if it doesn't have the equal sign, we're going to talk about the parentheses. When it actually includes the equal sign, we're going to talk about brackets. So these symbols are equivalent to each other, except that here there's no letter y and there's no letter x because we assume that domain has the x values and range has the y values. And really here we would just have two numbers. So the x values the smallest x value and the largest y value. Same here. Sorry, the smallest x value, the largest x value, the smallest y value to the largest y value. And it's just either parentheses or brackets or a combination of both. Set builder notation is actually very similar to inequality notation in the sense that we're going to be putting little curly braces, right, around a statement, and we're going to say x, and we have a vertical line, which means such that the statement about x. So usually you'll see something like this. You'll probably see something that says x, like D is the domain, is the values of x, such that x is greater than 0. That is one way of saying that. And all this really means is you're sort of describing a rule for the x values. And you could do a similar thing for the range. Right? For the range, we could say r, curly brackets or braces, y, ranges all the y values such that y is less than 0. It really just comes down to a rule. What rule is it that you want to apply to the y values, and what rule do you want it to apply to the x values? So very similar to this right here. Usually it's going to be the same notation that you use here. The exact same notation is going to be inside. You're just going to be adding a few more symbols to that. Okay? Again, as we go through more of this, you're going to get comfortable and really understand what this is talking about. So let's talk about this for a second. We're dealing with bounded sets as one of the types of sets that we're dealing with. A set is really just a series or a combination of numbers, right? So like rolling a dice, they have a total of 6 possibilities in that set. That set includes 1, 2, 3, 4, 5, and 6, right? When you're using cards, when you're using, really a set is just what encompasses the space of possible values. Here with this number line, the set would be between -5 and 1. Here would be between 0 and 4. All the other values do not exist, right? So as a reminder, whenever we have an open circle, we're dealing with less than and greater than, or parentheses, because it doesn't include that endpoint. And when it includes it, when it's actually bubbled in, we're going to use the less than or equal to or brackets, right? The brackets represent that it includes the endpoint, and here it means that it doesn't include the endpoint, so it excludes the values. So let's do an example here. Here we have an example of a bounded set. How do we know that it's bounded? Because it is bounded by 2 values. It stops. It exists between 2 values, a minimum and a maximum. So here we would write it the inequality notation like this. Since we're dealing with the horizontal values, we're going to talk about the value or the letter x. So x is between 2 numbers, the smallest number on the left and the largest number on the right. Now, which symbol are we going to be using? Are we going to be using the less than or equal to symbol or just the less than symbol? Well, since it's a closed dot, we're going to be using this symbol right here, the less than symbol. And we're always really going to be using the less than symbol. Less than or equal to, less than or equal to. Since we're writing things from least to greatest, we're really never going to be using this symbol right here, that notation, unless we have a scenario where we go to positive infinity, then we're going to be using the other symbols. But when it's bounded between 2 values and you're using the smallest and the largest, we're going to be using the least symbol. The interval notation, remember, is very similar to this. So the only thing that changes for the interval notation is we remove the x value and we just write the number, the smallest number, and the largest number. And since we're dealing with less than or equal to, right, the equivalent is a bracket. So we're going to say that the x values exist between -5 and +1. And we put those 2 numbers in a bracket because we know that it includes the -5 and it includes the +1. Finally, we have a set builder notation. So all we're going to say here is like the domain, curly brackets, is a set of x values such that it's just a vertical line, like dividing these 2 spaces, and then we copy this piece down. We copy that right here. So we say such that x exists between 1 and negative 5. Let me make this a little bit cleaner. So here we have it. We have inequality notation that includes the inequalities. We translate to using the actual brackets because it includes both endpoints. And then stability notation is the exact same thing as inequality, except that we're adding curly brackets and which value we're talking about in particular. Let's try this next one over here for this one as well. Since it's horizontal, we're dealing with x as well. So for inequality notation, remember we're going to be writing the smallest value first. So x is going to exist between two values. The smallest one is 0, and the largest one is 4. Now, notice how at 0, it includes the point. It includes the endpoint 0. So because it includes it, we're going to put the less than or equal to symbol. On the other side, the 4 does not include it. So it's everything up to 4 except for 4. So like 3.999 would work, but 4 does not work because it has an open circle. Remember, open circles, we use the non-equal part. So we just put the less than symbol. We're always going to be using the less than symbol when we organize it from least to greatest. So less than, less than. Now we convert this to interval notation. Remember, interval notation, we remove the x value and we just put the smallest and largest number. So we're going to do that. We're going to put the smallest number, the largest number, and then we use parentheses or brackets. Because it's equal or closed circle, we're going to use a bracket for this side, meaning it includes 0. And over here, because it does not include 4, we're going to use parentheses. So these two mean the exact same thing, right? It goes from 0 to 4, from 0 to 4. Here it includes 0, and here it does not include 4. And lastly, we have set builder notation, which is really just adding the curly braces. We say x such that it's between 0 and 4. And that's supposed to be a 4 here at the end. And braces. That's a 4. All right, well, why don't we try the one by ourselves? Try this one out. Now we're dealing with vertical lines. So because it's vertical, here we have a scenario here on the left and one on the right. Because it's vertical, the only thing we're going to change is the letter Y, or the R for range. So why don't you pause this and give it a try yourself and see what you got. Okay, so let's do this. We're going to write the inequality notation first. For here on the left, right, it's always least to greatest. So it's going to go from 0 to 6. So I can say y is between 0 and 6. Earlier we used x because it was horizontal. Now we're using y because it's vertical. So notice how at 0 it does not exist. So we're going to put an open circle, which is the less than symbol. At 6, it does include the 6, so we need to put the equal symbol underneath. Now for interval notation, remember, we take the exact same two numbers, we remove the stuff in the middle, and we just put the numbers, the least number and the largest number. So we can say it's between 0, 6, and then we just go ahead and include when it's open, remember we use parentheses, and when it's closed, right, when it equals, we use the bracket. And that represents that the smallest number is 0, the largest number is 6, 0 is not included, and 6 is included. The bracket means that the 6 is also included in the process. Lastly, we have set builder notation. Since we're dealing with y's, we're going to be dealing with the letter R for range. So we can say R, the range is a set of y values such that y is between 0 and 6. Remember, we really just copied this inequality symbol in here, and we're just saying that we're talking about the y values. So y such that y is between 0 and 6. Let's try this other example. Here we have between the two numbers 2 and 7. Remember, we're going to be putting the y value first. The smallest number is on the left. The largest number is on the right. Because they're open circles, we do not put the equal symbol. So y is between 2 and 7. Moving over to interval, we remove the stuff and we just talk about the 2 and the 7. And we just want to worry about whether it's parentheses or brackets. Since it does not include the endpoints, we're going to use parentheses. That means that the y values exist from 2 to 7, not including the endpoints, hence the open circles. And finally, set builder notation is just like inequality notation, except we're going to add the curly braces and that extra notation. So R is a set of y values such that y is between 2 and 7. This last notation is not used very much. We will usually focus on inequality and interval. As you move on to higher math, you're going to use a lot of interval notation, but it's good to know set builder just so we know when we're reading it or in a word problem or something, we can actually understand what we're talking about. But this is just a fancier way of saying this. So these are bounded sets because it's bounded by two endpoints. Everything exists in between. Let's talk about unbounded sets. Unbounded sets do not exist between 2 points. Usually it goes to infinity, either on one direction or the other, or in both directions. So unbounded means that it's not trapped between two spaces, and it exists forever in one direction or in both directions. That's what it means to be unbounded. So here we have a scenario where x, because it's horizontal, x goes from 0 all the way to positive infinity. Here we say x goes from negative 8 all the way to negative infinity. So when you're dealing with these examples, right, the only thing we're going to start including now is either positive infinity or negative infinity as the answer. We still write everything the exact same way, right? The inequality notation is still, the inequality symbols is still from least to greatest, but now we're going to be including, instead of endpoints being numbers, some endpoints are going to be infinity or negative infinity. So let's look at this example. We go from 0 to positive infinity, so you can write this in two different ways. You can say x is between 0 and positive infinity. Now, because it does not include 0, we're going to put no equal sign underneath. And because you can't ever really reach infinity, we're going to put the less than symbol underneath as well. You can also write this a little bit differently. You can also say x is just everything bigger than 0. So when you're talking about unbounded sets, when it goes to infinity, you can write it like a bounded set where it's between two values, where it never really gets to infinity, or you can just say x is everything bigger than 0. 1, 2, 3, 10, 20, 100, all the way to infinity. The interval notation, we're going to be taking these two values again, right? We're going to write the smallest one first, the largest one second, and then because it does not include the endpoints, we put parentheses. Set builder, very similar to inequality notation, so we say domain, curly braces, the set of x values, such that you can say x is greater than 0, or you can say x such that it's between 0 and infinity. So it really just depends what inequality notation do you use, between the smallest and largest, or just greater than the smallest, and then you can go with both, whichever notation you prefer. Over here we have the smallest value is negative infinity, the largest value is negative 8. Least to greatest, left to right. So we put x is between negative infinity and negative 8. Now at negative infinity, you can't ever reach it, so we consider that an open circle. And at negative 8, it's a closed circle, so we put the equal symbol underneath. Interval notation, same thing, right? We write the smallest value, the smallest value, and the largest value. Now, because it does not include negative infinity, we put parentheses. Because it actually includes the negative 8 and it's a closed dot, we put the brackets. Hopefully we're feeling better about the parentheses and the brackets, right? The not included, the open circle is parentheses, and the bracket is closed. Now, to help you understand why negative infinity or positive infinity are always going to be open circles, is because whenever you get to that number, to infinity, whatever that number is, you're always going to be able to do one more. That's the power of infinity, that there's always one number ahead of infinity, like infinity plus 1. So if you get to like 10 million, there's always going to be one number after that, 10 million and 1. If you get to 10 trillion, there's always going to be another number after that as well. That's what infinity means, right? That it never ends. So you can't ever say it's a closed circle of infinity because you're never going to reach that number. There's always going to be something greater than that. Continue to grow, continue to go. So we just treat it as an open circle because it just continues. Finally, we have set builder notation. Okay, we're going to write that inside of our braces. That's really it. So we say domain, curly braces, x such that it's between negative infinity. Let me make some space here. Negative infinity and negative 8. Now, the other notation you can also use is you can say x such that x is everything less than or equal to negative 8. Right? If x is everything less than negative 8, then it's going to go for negative 8 and everything below it. Those are the two different notations you can use. So why don't you try this one on your own? Go ahead and pause the video and then play it and continue hearing what I have. Remember here, because it's vertical, we're dealing with the y values. We're dealing with range. Give it a try. So the smallest number we're dealing with is 3. The largest number we're dealing with, because we have a positive arrow going upward, it means it's going to go all the way to positive infinity. So y is between 3 and positive infinity. Now, because it includes the 3, we put a closed circle. We put the less than or equal to. And because it can't ever get to infinity, we just put the less than symbol. Another way to say this is you can say y is between 3 and infinity, or y is just everything bigger than 3. Those two statements are the same. This just means y is going to keep going. All the numbers bigger than 3 is going to keep going. Or you can put it between infinity and the 3. Interval notation, we write it the smallest and largest. So we go from 3 to infinity. It includes the 3, so we put a bracket. It does not include infinity, so we put parentheses. And then sub-builder notation, whichever notation you prefer here with inequality, just put it with the curly braces. So we have range for y, curly braces, y such that y is greater than or equal to 3. Or the other notation, y such that y is between 3 and infinity. Notice how the infinity, it's already assumed to be positive. You don't have to put a plus. You do have to put a negative if it's negative infinity. But the plus and positive, it's just sort of implied that it's the same thing. All right, lastly, this last topic is now putting 2 and 2 together. So notice how now we are combining sets. We have 2 possible values, 2 x values or 2 y values. There's several directions. So to combine these, we use this letter U, which means it's the union, right? The union between these 2 sets. It's like connecting them together. It's combining the left side and the right side. And all you do is you cover one side over here, like cover this side, and focus on just this side. How would you describe that? Using the inequality notation, put the letter U, and then describe that separately. So you're basically doing two problems in one. You're doing the left side, write your solution, do the right side, write your solution, and in between them, to connect them, we put the letter U to say union, or the word or. That's what it represents. It's going to be on the left side or on the right side, on the bottom side or on the top side. That's really all the letter U means for union. So let's try it out. Here on the left, we're going from negative infinity to negative 5. And over here, we're going from 2 all the way to positive infinity. So we're just going to write that interval like that. The inequality, everything. We say y is between infinity and negative 5. Notice how the infinity, it doesn't reach it, so we put open. And at negative 5, it's also open, so we just leave it like this. And then we do the right-hand side. We do another inequality symbol over here. So we say, instead of y, it should be x, because we're dealing with the horizontal values. So I'm going to erase that real quick. And put the letter, put the letter x right in there. It's not erasing for some second. Alright, let's just redo this. It's not erasing things, so I'm going to write it again. On the left-hand side, which is this side, right, it's between negative infinity and negative 5. Negative infinity, it's the x value, negative 5. On the right-hand side, we have from positive 2 to positive infinity. So 2 to infinity. Now at 2, it does actually equal it. And to connect these two, right, the answer on the left and answer on the right, we're going to put the letter U, capital U in between, meaning it's combining this answer or this answer. That's where the x values can exist. It can exist on the left or it can exist on the right. That's really all that we're adding now. We're adding the letter U because we're combining multiple sets now in our situation. Interval is the same thing. It's still least to greatest. So we can still say negative infinity to negative 5. It's open because it doesn't include both directions. We put the letter U in the middle, and then we say from 2 to infinity. It includes the 2, but it does not include the infinity. Personally, interval is my favorite. It's just very shorthand. It's a lot quicker to write. It doesn't include it with parentheses. It includes it with the brackets, least to greatest. It's just less work. Personally, that's my favorite method to use. Set builder, same thing. Remember, same thing as up here. The only thing we're doing is we're adding the squiggly lines. So we're going to say domain, squiggly line, x values, such that copy everything here underneath. And that's really how you're going to put. So whatever you have for inequality with the union, put it right under here. And we're going to go blah, 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 blah. Union, blah, 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 blah. Braces. And that's coming from this top section. Alright, try this next one on your own. Here we're dealing with the y values because it's vertical. Try writing this one as a union. Remember, you're going to go from least to greatest. From negative 2 to positive 3. And from 5 to infinity. Write the inequality notation, write the interval notation, and then write your set builder notation. I'm going to write the inequality and interval, and you can assume that the last one's going to be the same as inequality. So here we have least to greatest, right? So on the lower side, we have from negative 2 all the way to 3. At negative 2, it includes it, so we put the equal symbol. And at 3, it doesn't include it. Remember, it's least to greatest. So when you're dealing with y's, it's from bottom up. Least to greatest is at the bottom, greatest is at the top. We put the letter U for or, and then we go from 5 all the way to infinity. The 5 is open, and infinity is also open. So there we have our two sets, the bottom or the top. In our notation, you go from smallest to largest. It includes the -2. It does not include the 3 because it's an open circle. Union from 5 to infinity. It does not include either ends. And then finally, set builder notation. Remember, all we're going to do is we're going to add the braces. So we say y such that all of that is going to go right here. Or la 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 la. Hopefully, this is a quick introduction and sort of gets you flowing into the thinking of stuff. We're going to be dealing, as I said, we're going to be dealing with graphs that look in this direction. So our goal is to move on and do graphs that look with x and y at the same time. But I wanted to show you what it would look like to do x's separately and y separately so we can eventually do it together on an actual graph. All right? If you have to go back and sort of review a little bit about what notations we're using, go ahead and go back, pause it, rewind it, do what you need to do to just let things sink in. Remember, when there's new information, it's harder to process. So just give it some time. We'll talk about this more in detail next week, and we can keep talking about how do we deal with these 3 different notations. But remember, the most popular ones are going to be inequality and interval. And as I said, my favorite is interval because of the simplicity behind it. All right, guys, let me know if you guys need anything. And as always, I'll calculate later.